Hello all, today in this video I'm going to make a continuation video of the previous video. So previously we have worked with email spam detection with different algorithms, machine learning algorithms. In this work we are going to work with naive machine learning algorithm and going to make an comparison that which machine learning algorithm is providing better results. For that initially we are importing the libraries which we are needed, and then we are loading the data set. This data set you can just give us email spam detection data set. Kaggle means this data set will get downloaded. It is having nearly 3 columns, which is an serial number, unnamed column, then email text and email type. Then we are getting the info of the data set. By this you may notice that the first serial number column is the integer type and other two columns are object type. Then we are checking whether our data set is having any null values. You may notice that email text is having some 16 null values. We have to omit it. For that we are moving to dropping that null values. And also this, if you notice the first column, which is the unnamed column, it is of no use, so we can drop that also. For that we are dropping the unnamed column, and moreover we have dropping the things which we are checking whether it is null. So after that we are again checking whether the data set is having any missing values. Now you may notice that unnamed entry is not fine, and also the all other entries is seen, by which you may notice that no null values is found. Then we are getting the shape of the data. Then we are making a plot within for the email type, within which we are making that which uh, data, that is whether say female or phishing email is having high content. When comparing to phishing email, say female is found in many entries. Then we are moving to the train test split function. For that we are determining the x variable. Within the x variable we are calling the email text, and within the y variable we are calling the email type. Then by using this x variable and y variable, and the test size is 0.2, that is 20% for testing and remaining 80% for training. We are determining variables like xtrain, xtest, ytrain and ytest by the use of the train test split function. Then we are using feature extraction. Since our data is in the text model, we have to convert it into vectors. For that we are using the tfidf vectorizer. It is converting our data into vectors. This vector only we will be using in the model training and its evaluation. First we have worked with the logistic regression and we have displayed its predictions, then confusion matrix and also the classification report, within which we can notice the values of precision, recall, F1 score, support and accuracy. Here the accuracy for logistic regression is 96. Then we have worked with support vector mission. For that we have got the predictions, confusion matrix and classification report. For SPM the accuracy is 97. Then we worked with the catboost. For that we have got the predictions, confusion matrix and the classification report. For catboost we have got the accuracy as 96. Then we have worked with passive aggressive classifier. For that we have got the predictions, confusion matrix and also the classification report. For this the accuracy is 96. Then we have worked with the random forest and we have got the predictions, confusion matrix and classification report, and we have got the accuracy as 96%. In this work we are working with naive Bayes, that too multinomial naive Bayes. For that we are initially the library which we are needed, and within that library we are calling within the function. That function we are using for training and testing. Training is done by use of the fit function, testing is done by use of the predict function. With fit function we are calling the training variable, since it's training, and within the testing or predict function we are calling the predict variables, and then we are displaying the prediction values. So the prediction values is displayed within an array. Then we are making a confusion matrix. Within the confusion matrix, previously if you see means our data size is nearly 70,000, but here we are getting only some values in the confusion matrix. It is since we are using only the test data for by plotting the confusion matrix, and the test data uses only 20% of the data. The remaining 80% is taken by training. Then we are plotting the confusion classification report. By this, for naive Bayes we have got 94% accuracy. Then we are making a comparison with the algorithms we have declared so far, like logistic regression, support vector mission, catboost classifier, passive aggressive classifier, random forest, and naive Bayes. And if you notice, means here SVM is providing better accuracy. Then comes three models with the 97, which are logistic regression, catboost classifier, and passive aggressive classifier. Then after that, random forest takes the place with 96% accuracy. Finally, the naive Bayes, which we have declared now, it is showing the least accuracy with 95. All these models we have plotted within a bar plot. So this is the bar plot, and you may notice the naive Bayes is the one which is having some least accuracy. In the next video, we will be working with KNN algorithm and will make an comparison with that. Thank you.